Have you ever pondered the possibility of intelligent life thriving in the depths of a gas giant? That's the question we're delving into today. Now let's talk about gas giants. These celestial bodies are essentially mammoth atmospheres with a small rocky core, dominated by gases like hydrogen and helium. They're a fascinating enigma in our universe, their depths shrouded in mystery and presenting conditions that are incredibly unique. We're talking about pressure so intense it could crush a spacecraft like an aluminum can, and temperatures that could either freeze you solid or melt you away in an instant. All of these factors make gas giants a daunting subject of study, but they also make them all the more intriguing. After all, it's often in the most extreme conditions that life surprises us the most. So, under these extreme conditions, could life possibly exist? Life as we know it requires certain conditions, but what if life elsewhere plays by a different set of rules? When we think about life, we often picture a scene here on Earth. Lush green landscapes, a variety of animals, and of course us humans. However, life on Earth also exists in some of the most extreme conditions imaginable. In the depths of our oceans, near hydrothermal vents, we find organisms known as extremophiles. These creatures thrive in environments once thought uninhabitable, where water temperatures can exceed 200 degrees Fahrenheit, and the pressure is equivalent to having 50 jumbo jets piled on top of you. In the driest deserts, amid scorching sands and minimal water, hardy organisms persist. And even within the icy confines of Antarctica, life has found a way. These examples bring us to a thrilling question. If life can adapt to these extreme conditions on Earth, might it also survive in the even harsher environments of gas giants? Gas giants, massive planets made primarily of hydrogen and helium, present conditions utterly alien to us. There's no solid ground. Temperatures can plunge to hundreds of degrees below freezing or soar to thousands above, and the pressure can be thousands of times greater than Earth's atmospheric pressure. But let's imagine for a moment that life, as adaptable and resilient as we've seen it to be, could exist there. What might it look like? Perhaps it would be a creature of the clouds, able to withstand crushing pressures and extreme temperatures. Maybe it would be a being of energy, thriving on the storms that roil these gas giants' atmospheres. The possibilities are as endless as they are fascinating. And while we can't say for certain whether such life exists, exploring these ideas expands our understanding of what life can be. It pushes the boundaries of our imagination and the limits of possibility. Given the resilience life has shown on Earth, it's not entirely outlandish to imagine it surviving the extreme conditions within a gas giant. Scene script. Assuming life does exist in these depths, how might they communicate in an environment dominated by endless storms and turbulence? Let's delve into this intriguing possibility. The turbulent atmosphere of a gas giant filled with endless storms and fierce winds is a far cry from the tranquil surroundings we're used to on Earth. Yet it's worth considering that if life does exist here, it must have adapted to communicate in this tumultuous environment. Imagine a world where communication doesn't rely on sound or light, but on the intricate patterns of the atmosphere itself, the ebb and flow of the storms, the shifting currents of the winds. These patterns, ever-changing yet precise, could serve as the language of our hypothetical gas giant dwellers. This idea might seem alien to us, but it's not entirely unheard of in nature. Let's take bees as an example. Bees, those tiny insects we often overlook, have a fascinating way of communicating. They use intricate dance patterns to relay information. They can tell each other where to find food, how far it is, and even if there's danger nearby, all through the precise movements of their dance. So, who's to say that the inhabitants of a gas giant couldn't have developed a similar system, but one that uses the swirling winds and shifting storms as their canvas? Their entire language could be written in the atmosphere, a symphony of patterns and rhythms that we, with our limited understanding, could only begin to comprehend. And just as we've decoded the dance of the bees, perhaps one day, we might learn to read the atmospheric ballet of a gas giant. It would be a language unlike anything we've ever encountered, a testament to the adaptability and inventiveness of life. Is it so far-fetched to believe that life, in its endless quest for survival, could have found a way to communicate in such extreme conditions? Perhaps not. Life on Earth has shown us that it can adapt to the most inhospitable environments and still find a way to thrive. In the absence of light and sound, such unique methods of communication could be a necessity. Having considered the existence and potential communication methods of these beings, the big question remains: how might we interact with such life forms? To start, we'd need to decode their atmospheric chatter. Imagine it like learning a new language, only this one is expressed through swirling patterns in a gas giant's atmosphere. Now, sending a probe into the depths of a gas giant wouldn't be a walk in the park. We'd be dealing with extreme pressure, temperatures, and turbulence that could crush or fry our most advanced technology. But let's consider for a moment that we could design a probe capable of surviving these conditions. It would need to be equipped with sensors to detect and decipher the atmospheric patterns, and perhaps even emit patterns of its own, attempting to establish a dialogue with these beings. While it's all speculative, the thought of such interaction opens up a whole new realm of possibilities, doesn't it? From the possibility of life in gas giants to the unique ways they might communicate, we've certainly journeyed deep into the realm of speculation. We've traversed the enigmatic landscapes of these colossal celestial bodies, delved into the potential for life to thrive in their extreme conditions, and pondered on the intriguing concept of communication through atmospheric turbulence. Our curiosity has led us to contemplate how we might interact with such hypothetical beings. Would we decode their atmospheric signals, or perhaps find a way to replicate them? The answers remain shrouded in the mysteries of the cosmos, but the questions themselves spark our imagination and fuel our relentless quest for understanding. The universe is an endless expanse of wonder, a canvas for the extraordinary and the unimaginable. While we're yet to discover such life, who knows what the depths of gas giants hold? After all, the beauty of space exploration lies in the infinite possibilities.